The first thing that you need to focus on is understanding terminology. In science, we use terms that have very specific meaning. It allows us to express our ideas accurately. Not knowing the exact definitions of terms is a leading reason why students have trouble answering chemical questions or following chemical arguments. Whenever you encounter an unfamiliar word, look it up or ask me about it. I suggest keeping a notebook with definitions for all terms that we learn in class. On the last slide of each lecture, there is a section with terms you need to remember. These terms will come up again and again in class, and it won't be possible to keep up with the material if you don't remember them. I will also ask you to define some of these terms on tests and quizzes. The second thing that you need to focus on is quantitative reasoning. We only use basic arithmetic in this class, but you shouldn't perform arithmetic operations blindly. Chemistry describes the real world, and when you are solving problems, you want to translate information about the real world into numbers. Consider the following example. Chemicals are usually weighed in containers. Assume that you have found that a container with a chemical has a mass of 12.5 ounces, and the same container, when empty, has a mass of 11 ounces. What is the mass of the chemical then? Pause the video and try to figure it out. You have here two numbers, 12.5 and 11 ounces. But I won't tell you what you need to do with these numbers. You need to think how arithmetic operations relate to the real world. This relationship is usually common sense. Why does the container with the chemical in it weigh more than the empty container? The extra mass must be the mass of the chemical, right? So, mass of container, which is 11 ounces, plus mass of chemical, which we don't know, equals mass of container with chemical, 12.5 ounces. If we now express the mass of the chemical, we will find that it will be equal to the mass of the container with chemical minus the mass of the empty container. So 12.5 ounces minus 11 ounces, 1.5 ounces. We were not told that we needed to subtract the two numbers we had, but used common sense to figure it out. You will use very similar reasoning throughout this course. When you are faced with a problem, ask yourself, what do you know and what do you need to find out first? Concisely write down this information. Then ask yourself how what you need to find is related to what you know. You will need to use common sense and often also the definitions of the terms that we learn. That is part of the reason why knowing the terminology is so important. We will be talking more about how to approach chemical problems throughout this course. The final thing that you need to keep in mind is that it is not sufficient to just be able to follow an explanation of a concept or a solution to a problem when I explain it. You need to be able to explain the concept or solve the problem yourself. To get there, you will need to practice. Once you think you understand the concept, stop the video lecture, put away your book, close your notes, and try to explain it yourself. Write down your explanation, then go back to the lecture, the book, and the notes, and check if you got the explanation correctly or missed anything. When you think that you know how to solve a problem, close your notes and try to do it again. Can you reason out the sequence of steps that get you to what you need to find? Practice solving similar problems that I will provide. The more you practice, the more confident you should become at answering chemical questions.